Hi everyone, in this video I'm continuing to look at question 14 of the 2020 Baulkham Hills Extension 1 trial exam. So I've just finished working through part A, which had a whole bunch of subparts. This part B has only got one part to it, and it says if alpha and beta are the roots of the equation x squared plus mx plus n equals 0, find the roots of nx squared minus mx plus 1 equals 0 in terms of alpha and beta. So basically, to find the roots of a quadratic, we're essentially finding the values of x that set that quadratic equal to 0. Typically, we use the quadratic formula for that. There's a few other methods, but you know the quadratic formula is always going to get you there. I guess the only complication with this question is that we want it specifically in terms of alpha and beta. So the quadratic formula alone isn't going to get us what we need, but it's a good start. So let's take a look. So here I've written out what we're dealing with. As I mentioned, I think the quadratic formula is the place to start. So I'll just write that out. You know, you would have seen this over so many years that it's just one of those formulas you have burned into your memory. So I'll just write it as the values of x that will set a quadratic equal to 0. In general terms is negative b plus or minus root b squared minus 4ac onto a, and that's where we've got a, b and c as being the coefficients. A is the coefficient of x squared, b is the coefficient of x, and then c is our constant. So I guess in terms of applying that to this quadratic here, the one that we want to find the roots of, that's going to be negative b, which in our case is negative m, so we've got to be careful with our negatives, plus or minus the square root of negative m squared minus 4 times a, which is n for us, times c, which is 1, and that's all divided by 2n. So I might just clean this up a little, so these two negatives will cancel to give us a positive m plus or minus the square root, and this minus m squared would be minus 1 squared, which is 1, times m squared, so we get m squared, and this will just become minus 4n, and that's all over 2n. And that's pretty much as far as we can go with our quadratic formula. It's a good start, but if we were to just leave that there, I don't think we'd get the full marks for this question, because they want it in terms of alpha and beta, where alpha and beta are the roots of this other quadratic that we're told about. So I think to make the link, what we need to notice is that in this first quadratic, we have an m and an n, and in this second quadratic, we also have an m and an n, albeit with a different sign. But the way we can connect m and n to alpha and beta is through our sum and product of roots formulas. So if I start with, say, the sum, let's say note the sum of roots. In our case, if we've got roots alpha and beta, then alpha plus beta would be equal to, in general terms, it's negative b on a, where b again is the coefficient of x and a is the coefficient of x squared. So in terms of this first quadratic, the sum of the roots would equal negative b, or negative m, divided by 1. And so what we could therefore say is, we could say, if we just want to isolate m, that's going to bring the negative over, we'll just have negative alpha plus beta. And clearly that's going to help us because we've got some m's here, and we'd like to just be able to substitute in something that's got alpha and beta. Now, to get a similar thing, but with an n in terms of alpha and beta, we can use the product of roots result, and according to that, alpha times beta, so the product of the two roots, will be equal to c on a. And so in the case of the first quadratic, that'll be c, the constant, which is n, again divided by the coefficient of x squared, which is 1, so n is simply alpha times beta. So now what we can do is we can take this value of m and n in terms of alpha and beta and plug it back into our quadratic formula result, and hopefully it simplifies without too much difficulty. But that's essentially the question done. So we can say therefore x will be equal to m, which is negative alpha plus beta, plus or minus the square root of m squared, so negative alpha plus beta squared, minus 4n, or minus 4 alpha beta, and that's divided by 2n, or divided by 2 alpha beta. So that's the basic substitution. So we want to clean this up. I think for now I'll just leave this negative alpha plus beta because that's pretty clean. But we want to clean up what's under this square root. We need to be really careful with our negatives and squaring again. So it'll be the square, negative 1 squared times alpha plus beta squared. So that's really just alpha plus beta squared. The negative 1 disappears. Minus 4 alpha beta on 2 alpha beta. I think if we keep our negative alpha plus beta plus or minus, what we can do here is expand this square. So it'll be the first one squared plus twice the product plus the last one squared, and then we've got this minus 4 alpha beta off the end. And that's again all over 2 alpha beta. And then that's negative alpha plus beta plus or minus, so we'll have an alpha squared. 2 alpha beta minus 4 alpha beta would be minus 2 alpha beta plus beta squared over 2 alpha beta. And hopefully you notice that there's probably still enough room to write a few more lines. It's negative alpha plus beta plus or minus, and hopefully you notice what's under this square root sign can be factored as alpha squared minus beta squared. So we, alpha minus beta all squared. So we started with alpha plus beta and we expanded it, but then when you subtract this 4 alpha beta, you end up with essentially what can be factorized as alpha minus beta squared. Alpha minus beta squared, because if I was to expand that, I'd get alpha squared minus twice the product, or minus 2 alpha beta plus beta squared. So I guess at the extension 1 level, you're expected to be really comfortable with both expanding a square and factorizing it, whether it's something plus something or something minus something. You kind of need to just be so comfortable with that you can see it without any guidance, because I guess that's the trickiest part of this question. Possibly there's extension 2 students out there who get caught up at this point and don't know what more they can do, but the expectation is that you can see that can be factored. And then we've got our 2 alpha beta at the end. Alright, at this point I will need to turn over, but hopefully you can see we've got the square root of something squared, so we're just going to end up with this alpha minus beta by itself. So let's turn over and we'll say therefore our x is equal to negative alpha plus beta plus or minus, and then we'll have our alpha minus beta. Alpha minus beta, and that's all divided by 2 alpha beta. And at this point maybe it makes sense to now work through each of our cases one at a time, the plus and the minus. So therefore we can say x is equal to negative, maybe I'll keep it in brackets and expand it in the next step. So alpha plus beta plus alpha minus beta on 2 alpha beta. So that's one solution, one root of the quadratic. Or x could be equal to negative alpha plus beta minus alpha minus beta on 2 alpha beta. And the whole way through this question we've had to be really careful with our minuses and double negatives and squaring negatives, and you just got to be quite careful, but as long as you're careful you'll get there. So now let's do our expansion. So we'll expand this minus through, we'll get minus alpha minus beta plus alpha minus beta on 2 alpha beta. If I just stick with this, the minus alpha plus alpha, they'll cancel, and the minus beta will get us minus 2 beta on 2 alpha beta. And then these 2's cancel, these betas cancel, and you end up with the first solution being negative 1 on alpha. And if we follow this one through, we'll end up with x equals negative alpha minus beta minus alpha minus gets us plus beta on 2 alpha beta. And in this case, the minus beta and plus beta cancel. So we end up with minus 2 alpha. Minus alpha is minus 2 alpha on 2 alpha beta. The 2's cancel, the alphas cancel this time, and so we end up with minus 1 on beta. So essentially, at the end of the day, what we've shown is that if alpha and beta are the roots of this first quadratic, then the roots of this second quadratic are the negative reciprocals. So instead of alpha and beta, our roots will be negative 1 on alpha and negative 1 on beta. And that's how you tackle that question. So hopefully that's all made sense. I guess a lot of students could probably get started. You'd hope that most Extension 1 students would know, hey, we're looking at the roots of a quadratic, let's use our quadratic formula. Hopefully you're very comfortable with that part. I think maybe plenty of students stop here and so give up a few marks because maybe they didn't read closely that we want it in terms of alpha and beta. So you've got to be careful there. And then to get it in terms of alpha and beta, you need to make use of this other knowledge that we have about quadratics, the sum and product of roots. And again, these are results that hopefully, because you would have learned them so many years ago, if you've kind of been diligent with your math over the years, they've been burned into your memory. You've just used them so many times that you can very easily pull them out and make use of them when you need to. And then from there, I guess that's the next big logical leap you needed, and the rest was just being very careful with the algebra, handling the negatives properly. And I guess from getting from here to here is maybe where the next set of students get caught up, because you just can't see how you could factor that and get the square root of something squared. But I guess as a tip, as an exam taking tip, often the way questions are written, when you're trying to simplify quadratics in terms of generic values instead of actual values, so where you can't just get out a calculator, often the question writers will write it so that you end up with something that can be factored as a square, a perfect square, either something plus something squared or something minus something squared, because they know that's then what's going to let you get rid of this square root and let things really simplify to something, quite palatable. So yeah, hopefully that's all made sense. In the next video, I'll work through the final part, 14 part C of this question 14. All right, tick boom.